Okay, so when you log in today, today's agenda, we are talking about the different types of chemical reactions. So, kind of our last week, we focused on sort of the basics of what chemical equations look like and how to write them, translating like from our names, from like our words to chemical formulas. And then we talked about balancing. So, we were kind of worried about the amounts of the atoms that were on each side of an equation. And so today we're at the second part of this unit is focusing on the different types of chemical reactions. And so what we're going to see today is there's sort of two main categories, I guess you could say, and those are called double replacement reactions and oxidation reduction, or sometimes they have this nickname redox. It's kind of like the short nickname for them. So those are kind of our two main categories or our two main types. And then within each of those, there are sort of other more specific types of reactions. And so it all depends on like, do you have one reactant and two products, or do you have two reactants and one product? Or if there are two reactants and two products, are they elements, compounds, one of each, that kind of stuff. And then some of them have specific types of compounds in them. So this one that's called acid-base neutralization, the reactants are always going to be an acid and a base. And so you should be able to recognize that because we learned kind of what the formulas of acids and bases look like in Unit 4. And so we should know if something starts with hydrogen, that's an acid, unless it's water. And we should know that if something has hydroxide, which is that OH ion in its formula, then that's a base. And so if you understand what those categories of compounds, what their formulas or their names should look like, you should be able to tell if something is an acid-base neutralization reaction. For this combustion reaction, this one's another one that's very specific. And as we're going to see, it always produces carbon dioxide and water. Those are always the products in that reaction. And then the reactants, one of the reactants is always oxygen. The other reactant is usually almost always a compound that contains carbon and hydrogen. Okay. And so some of them are very specific in the compounds and things that are in their reactions. Some of them, it's not very specific. There's sort of like a template, like there's one reactant, but it breaks down and makes two products. Or there's two products, but they combine and make two reactants, and they combine to make one product. So double replacement and oxidation reduction or redox. And then within double replacement, there are two kind of specific types of reactions that fall into the double replacement category. One is that acid-base neutralization that I just mentioned. The other one's called a precipitation reaction, and we'll talk about why it's called that when we get to that. Under the redox or oxidation reduction, there's four specific types: synthesis, decomposition, single replacement, and combustion. And so when we're going through today, if you are given a chemical reaction, you should be able to tell me, is it double replacement or is it oxidation reduction? And then you should be able to tell me which specific type within that. Is it acid-base neutralization or precipitation? Or if it's redox, is it synthesis, decomposition, single replacement, or combustion? So you should be able to tell me both of those things if you're given a chemical reaction to examine. Okay. So we're going to kind of go through some of the note stuff together. And then there are some videos in them. So I'm not going to make you guys watch the videos here on the live call. The videos you can watch on your own time, but we're going to go through sort of the information that's on there. And then your grade, your assignment today is there is an interactive assignment. There's kind of two parts to it. One part is you're dragging and dropping and kind of matching up and identifying what types of reactions you're being shown. And then the second part is sort of a practice quiz with some multiple choice type questions. So there's kind of two parts to it. So make sure that you do both of them when you do that. And we'll look at it and when we get there. And then there is an extra thing. This is not for a grade. It's just extra practice. So for those of you who feel like you need some extra practice, it's a vocabulary game. And so what it is, and it changes when you do it. So if you do it once and then you go back and redo it, it's going to give you different things. And so it's really good to practice with because of that. So it's going to have sort of our vocabulary terms, like it'll have all these different types, the names that we just talked about that's up here in the objective. And it'll have either definitions that match them, or it might give you an actual chemical equation that you have to match it to the correct one. And so it changes all the time. It's not always the same. So if you feel like you need extra practice or you want to take the time to make sure that you're really understanding that, then you have that as kind of an optional extra practice to do. Again, it's not for a grade, just the first one is for the grade. And then I will tell you that on Friday, we're going to be finishing up. On Friday, we're going to be focusing on one of these specific types of reactions, and those are the single replacement reactions, because we can actually predict if those reactions will take place or not. And so there's a specific reference chart that we use for that called the activity series. And so that's what our focus will be on Friday, is focusing on that specific type, and then learning if we can figure out, is the reaction going to take place or is it not going to take place? And if it does take place, what will the products be? And then next week on Tuesday, you will be taking your test for this unit, for Unit 5. So just to recap, we're doing these types today. Friday, we're going to be focusing on predicting single replacement reactions. And then next week on Tuesday, you'll have your review and your test on Canvas to work on. I will also tell you that next Tuesday, which is January 26th, I believe, we will not be having a Zoom call. So it kind of worked out well that we're testing on that day and we are not going to have a Zoom call. And the reason for that, you're not going to have Zoom calls for any of your classes next Tuesday on the 26th. The reason for that is that that day is a PSAT testing day. And so here on campus, we will only have students on campus that are testing for the PSAT. And those are pretty much going to be juniors, sophomores, and juniors who signed up for the test, and then some freshmen if you're an AVID. But so if you signed up for the PSAT, then you'll come to school and take it that day. If you did not sign up for the PSAT, then you'll be at home and you will just log into Canvas for all of your classes so that you're counted present for attendance, and you'll work asynchronously, meaning on your own on Canvas, since there won't be a Zoom call. So for our class, what you'll have on Canvas that day is you will have the kind of the review. So if you want to practice a little bit and review before you do your test, and then your test will be on there as well. Okay. All right. So our lesson for today, as I said, we're focusing on the types of chemical reactions. And so there's sort of an intro video here. Like I said, I'm not going to play the videos because a lot of times they don't always translate well on Zoom. Sometimes they, freeze or the sound doesn't go through. But definitely take the time to watch them, because they're really, the first one it's one of those Bill Nye videos. Okay. And so what it kind of goes over is he kind of shows you a couple of different, or a few different chemical reactions, because sometimes we think of chemical reactions as being very specific. But there's a lot of chemical reactions are happening around you every day, all the time. You just maybe don't think of it that way. So he kind of goes through and just shows a couple of them and kind of gives you an intro. But we're talking about the fact that chemical reactions they happen when we have our reactants. Our reactants will react with each other. And when they do that, they will be converted into different substances. Those are our products. And so what happens is I can have elements or compounds or both, kind of, it just depends. And what happens is the atoms will be rearranged. So it's not like I'm not doing magic. I'm not like turning an oxygen atom into a nitrogen atom. There's nothing like that. All I'm doing is rearranging. And so if I have compounds, I might break their chemical bonds. And once the chemical bonds are broken, then all of the atoms will rearrange and they will form different compounds and different elements on the product side. And so because they're forming totally different compounds and elements, they have different properties. Okay, they're completely different. And so there's a kind of a couple practice questions here that when you watch the video, you can kind of do them. They're fairly straightforward. But I want to go ahead and get to kind of the information for today. So here's your introduction. So I mentioned this when we talked about the objective, but you can classify chemical reactions into sort of these two main categories: double replacement and oxidation reduction. And then within each one of these, there are sort of some subcategories that are more specific types of reactions. So double replacement, the general definition is you're going to have two reactants. They're always usually going to be compounds. So you'll start with two compounds. And what's going to happen is usually they're going to be either an acid and a base, or there'll be some ionic compounds. And so what's going to happen is they're going to exchange positive and negative ions. So they're going to swap partners basically. And you're going to end up with two new compounds on the product side. The types of compounds are what make these two types specific down here. For the acid base, the neutralization reaction, your reactants are always going to be an acid and a base, and you're always going to produce a couple of specific types of products. For precipitation, you're starting typically with two just ionic compounds. And then your products, again, there's going to be something specific on there that makes it fall into this category of being called precipitation. Okay. And we're going to go into them in more detail when we get to the next part. For oxidation reduction, or I get tired of saying that because it's too many syllables. So you're going to hear me. I'm just going to start calling them redox reactions because that's the short version of the name. But for redox, this kind of reaction involves the transfer of electrons. And so in double replacement, there's just ions swapping partners. There's no electrons being transferred. But in redox reactions, you're changing maybe elements. Elements are becoming ions into a compound, or vice versa, might go the opposite way. And so there's electrons being transferred because somebody might be losing electrons and they're being transferred to a different element or a different atom to make a bond or something like that. And so the four subtypes here, we have synthesis. Sometimes you'll also hear it called combination. I usually use the term synthesis, but if you see combination, it's talking about this type of reaction. Decomposition, single replacement, and combustion. Okay. And again, we're going to talk about these four types in more detail as we go through. So down here, there's just some practice, and it's just having you tell me which of these types go in which category. So are they double replacement or are they redox? Okay. Because you have to know sort of which ones go into which category so that you're able to identify things better. Okay. So first, we're going to talk about double replacement reactions. So we talked about these are the ones where you have two reactants and there's an exchange of ions. And so this is kind of the generic equation for double replacement reactions. So we say a compound, so we have A, B. So A is the positive ion, the cation. B is the negative ion, the anion. And then here in this compound, C is the positive ion, D is the negative ion. Okay, so the blues are the anions, the reds are the cations. Because you remember when we write our names and formulas, the positive ion always goes first in a compound. So we have AB plus CD, and what happens is they're going to swap partners. So that means the positive ion over here, A, it's going to pair up with the negative ion from this compound, D. So my first product is going to be AD, and then my other product is CB, and it has to be written this way. I can't write BC because B is a negative ion, okay? C is the positive ion. It has to go first in the compound. So it does have to follow this pattern, okay? And so we'll see some examples of kind of what this looks like, but this is the general pattern, okay? There are two specific types that we're going to look at, and we're going to see examples and how all of them are going to follow that pattern that we just looked at. So acid-base, these are also called neutralization reactions, but you have an acid and a base, those are the reactants, and they always produce two things. Water is always one product, and the other product is always some ionic compound. And another word for ionic compound is called a salt. And so a lot of times for acid-base, you'll see this pattern where it's like acid plus base yields salt plus water. And salt is just a term for an ionic compound. So in this one, if I don't have these labels down here, you know, the acid, base, salt, water, I should be able to look at this and I should be able to categorize it as an acid base neutralization reaction and also as a double replacement reaction. Okay, because it is following that ABCD pattern. It's a little harder to tell, but if I look here, so here's hydrogen, that's my positive ion. That's like my A on the pattern, okay? Chlorine here, that's like my B. So this HCl, that's hydrochloric acid, this is like AB, and then plus, and then here sodium is the C from that generic pattern, and then hydroxide, this OH, that's the D. So those are my ions, like my AB plus CD. So if I follow that pattern, A, which is the hydrogen, goes with D, which is the hydroxide. And anytime you put hydrogen and hydroxide together, HOH, that's going to make water. So this H2O, we don't write it HOH, okay, because water's formula is H2O, but this is the AD, okay, and then CB, C is my sodium, B is my chlorine, and so they both go together. Okay, so it's following that ABCD pattern of the double replacement, but specifically it's acid base because when I look at these formulas, I should know, oh, this starts with hydrogen, that's an acid, okay? Specifically, it's hydrochloric acid. And I should know because this has an OH in its formula that that is a base, okay? Because anything that has hydroxide is considered a base, okay? The other thing you want to watch out for is that this NaCl doesn't have any subscripts, but that's because sodium has a +1 charge and chloride has a -1 charge. That won't always be the case. So be careful because like if this had been instead of NaOH, if this had been, I don't know, MgOH2, then this would be MgCl2. And then we would need to do something to balance the equation. But this is the basic pattern. And there's a little video here if you want to watch, because they're going to, on each one of these, there's going to be a visual example, a video that will show you what this type of reaction might look like in a lab. So if you're a visual person, definitely watch those because that will help you sort of make those connections as well. Now, the other type is the precipitation reaction. It's the same thing happening. Cations and anions are rearranging. It's following that ABCD pattern. The difference here, the compound, the reactants are not an acid and a base. They're just two different ionic compounds. They both have to be aqueous solutions. So notice these are both labeled AQ because precipitation literally means I'm making a solid, okay? And this solid, in this one, it's AgCl. That is called a precipitate, okay? So you need to know that word precipitate. So precipitate is a solid substance that is formed from two aqueous solutions in a double replacement reaction, okay? So the kind of the difference is here, I can still see they're following that ABCD pattern because like A would be the sodium and D would be NO3. And look, here it is right here. Na went with NO3. Ag, which is silver, that's my C, and it would go with Cl, which is going to be my B. And here it is right here. Okay. Now, later in the year, we're going to talk about like, how do I know this is solid versus aqueous? Because there are rules. There's a whole chart that tells us what kind of compounds are solid and which ones are aqueous, because some compounds dissolve in water and some do not dissolve in water. And so that's something we get more into later when we get to our unit where we talk specifically about solutions. But for right now, you just need to know that if it follows this double replacement pattern of A, B, C, D, and the reactants are both ionic compounds that are aqueous, like this, and when you look at the products, one of the products is aqueous, but the other product is solid, that is the pattern for a precipitation reaction, because you are recombining these cations and anions, they're switching around, and one of the products is an insoluble ionic solid. Insoluble means that it does not dissolve in water. And so when you watch the little video clip here, you're going to see they start off with two clear solutions. And when they mix them together, you're going to see little solid particles. And it looks like it's not solid, but when you look at it long enough, you'll see they are little solid flecks that are floating in the solution. And that is the precipitate that you would see. So down here, once you're done going through that, it has you practice. So you're basically looking at these reactions and you're analyzing them to see all of them are double replacement, but your job is to tell me, are they acid base or are they precipitation? And so you can use kind of the patterns that we looked at up here to help guide you through that. Because remember, they each have sort of one specific thing that makes them fall into their own category, okay? All right, the next section is going to go into detail on the oxidation reduction or the redox reactions. So again, this one, we're not talking about ions swapping places. We're talking about elements are going to lose or gain electrons. And so there's a transfer of electrons here. So one substance is going to lose some electrons and it's going to give it away to another substance. And so that transfer of electrons is what shows us that a chemical change has happened because there is a different substance. It's got different numbers of electrons now. So our four basic types that we're going to look at, we have synthesis, also known as combination, we have decomposition, we have single replacement, and we have combustion. So we're going to do just like we did on the other one and look at kind of a specific example of each one. Synthesis, okay? These are really easy to remember because if you know that the word synthesis means that you're making something. So if I synthesize, that means I'm making something, I'm creating something. And so synthesis reactions, you are starting with two reactants and making one product. Typically, the reactants will both be elements and the product will be a compound. Sometimes though, your reactants, it might be like an element and like a simple compound, and then your product is like a more complex compound. But the basic premise is you have, A plus B, and then over here is a compound AB because they're bonded together. Okay. So an example would be if we formed water from hydrogen and oxygen. So hydrogen gas, and if I add it with oxygen gas, and I got to add a little bit of energy in to get it to happen as well. But if I put these two gases together with a little bit of energy, then I'm going to get liquid water. Okay. There's also a video over here. It shows you a different one. This one, I believe it's reacting magnesium with oxygen that's in a flame, and you're making magnesium oxide. Okay. But that's the typical for synthesis, is that you have two reactants and you make one product, one compound as the product. Okay. Decomposition, they're the opposite of synthesis. You're going backwards. I have a compound and I only have one reactant. I am breaking it down and making two or sometimes more than two. The general pattern we talk about is two, but there are some where it might break down into three things. Okay. But the general thing is you only have one reactant. If you only have one reactant, that's decomposition. No other reaction only has one reactant. Okay. Everybody else has two reactants. Okay. So here it's the backwards of the one we just saw. I'm taking liquid water and I can actually do what's called electrolysis. I can apply some electricity to liquid water and I can actually create oxygen and hydrogen bubbles. I can break them apart into the gases. Okay. It requires a lot of energy to do that because water doesn't want to break apart naturally, but you can do it. There's another video here that's showing you a decomposition of a different substance that's not the water in the example here. I will say that decomposition reactions, these are the ones that you usually will see that triangle written above the arrow for heat, because if I just have one reactant, if it's just sitting, in a beaker or a test tube, just at room temperature, it's not going to start reacting by itself. So usually for decomposition reactions, you have to put some sort of energy in to get it to start. And so a lot of times that comes from a flame or a heat source. It could also be a light source. So there are some reactions that they decompose in the form of the presence of light, like hydrogen peroxide, the stuff that's in that brown bottle that you might have in your bathroom or something at home that you get at the drugstore. It is light sensitive. So it's hydrogen peroxide. It looks like this, except it's H2O2 liquid, and it breaks down into hydrogen and oxygen when it's exposed to light. That's why they keep it in brown bottles. And that's why after a while, even in the brown bottle, it'll start to decompose, and you should replace it once the date's gone on it. Okay. Next one is single. I think it's single. Oh, clicked the wrong spot. Sorry, guys. Single replacement. Okay, single replacement. Here you always have an element and a compound, and the element that's by itself is going to switch places with one of the elements in the compound. Okay. And so here's element and compound, and I end up with a different element and a different compound here. And so what happens is here I have A plus BC, and A is going to kick out B. So now B is by itself in elemental form, and A is in the compound with C. Okay. What that looks like in an actual equation, here is a compound. Okay. It's hydrochloric acid, aqueous. Okay. My equation's balanced. The 2 is just telling me the amount. That doesn't change the type of reaction. My element is zinc. It's a solid metal. And so what happens is zinc is a metal. And so metals will replace other metals, or metals can replace hydrogen because hydrogen's also positively charged in a compound. So zinc is a metal, and so it will try to replace this hydrogen. So what's going to happen, and we're going to go into more detail on this next time when we look at the activity series, because sometimes some metals are not strong enough to replace the one in the compound. And in that case, no reaction happens. But on this example, it is happening. So zinc is going to kick out hydrogen, and now zinc is paired up with the chlorine in the compound, and hydrogen's by itself. It's in its elemental form. Couple things I want to point out here. Over here is zinc, which is Zn. In this compound, Cl did not have a subscript, but over here it's ZnCl2. That's because when I look at the periodic table, zinc's charge is +2, chlorine is -1. So I have to have this 2 subscript as part of the formula, because what a lot of you would do is you would just write ZnCl. You would forget the 2. So remember, when you're writing your formulas for ionic compounds, you always have to check your charges, because this 2 subscript here, that's what made me have to add this 2 coefficient over here in order to balance it. And the other thing I want to point out is hydrogen. Hydrogen in this compound, it was just H, but remember hydrogen is on our list of diatomic elements or diatomic molecules. So now that hydrogen gets kicked out and hydrogen is the element, it's not in a compound, it has to have this 2 subscript, okay, because it's diatomic. So be careful on your diatomic elements and writing your formulas for ionic compounds on the single replacements, because that's what we're going to be practicing on Friday. And that's what a lot of times that's what people mess up on, is they forget about the diatomic elements and they forget to check their charges for writing the formula of the new compound on the product side. There is another example video here for you to watch to see a visual example. Okay. And then our last type is combustion. These I think are the most fun because you're burning something. And so in a combustion, you have a reactant that's usually a compound that has hydrogen and carbon. It's called a hydrocarbon. That's the term for these types of compounds. And these are actually organic compounds. And so we don't really learn how to name these compounds in this class. For example, CH4, this is actually called methane because organic compounds have their own naming system that's different from what we learn. And that's something that like my IB chemistry classes learn. But basically you always have some compound that's going to have carbon and hydrogen as your reactant. The other reactant is always oxygen. It's always O2. And your products are always carbon dioxide and water. And so that's kind of the basic pattern here. There's not like an A, B, C, D type of thing. It's very specific. It'll be the only thing that's going to change is the subscripts on your carbon and hydrogen. Okay. So this is CH4. Like I could have C2H8. I could have C3H10, you know. So the numbers, the subscripts for the carbon and hydrogen can change. And then that will change how you have to balance it. That'll change the coefficients. But it'll always be water as a product, carbon dioxide as a product, and your other reactant will always be oxygen. There are some times when this first compound, the hydrocarbon, it might have some oxygen in it too. There are some hydrocarbons that have some oxygen in them, but if it's mostly, if all it is CH and then maybe 1 or 2 O's, if the rest of it looks like this, if the rest of it's still O2 and then producing CO2 and H2O, it's this pattern, it's combustion, okay? And you'll see he actually, this video is actually showing what's called the whoosh bottle demo. Usually if we were here in person, like I would do this in class, like I usually do it because you guys can see, you can actually see that we make water in the reaction and we make carbon dioxide gas, okay? It also gives off a lot of heat. Combustion reactions are exothermic. That means that they give off a lot of heat. Anything that burns is going to do that. And so the last page just has a little summary video if you want to kind of watch that. It kind of summarizes the redox reactions in general. But then you're doing down here what you did on the other one. So there's some, different ones. You're going to tell me which type of redox is it, which of the 4 that are in here. And again, make sure you're looking at your patterns that you saw up in the notes presentation. After this, there is kind of a summary video that goes over kind of all the different types that has just some extra information. If you're feeling like I still don't understand it or I need a little extra help, this is here if you need to kind of write down any more notes or examples so that you have that to refer to. And then that is it. You're done with the actual lesson, okay? When you go to do the assignment, okay? So once you're done with that, you've got all your notes written down, your examples, you've done the practice that was in the notes. You're going to go to next, and then your assignment today is, like I told you earlier, there's kind of 2 parts. There's a drag and drop matching activity, and then there are some like practice multiple choice questions. What you need to make sure, so see how it says, I'm on page 1 of 3 right now, okay? So page 1 is the drag and drop matching activity. Page 2 is the practice quiz questions. Page 3 is where you need to submit the report so that I get the grade, okay? So up here at the top, it has kind of a summary. So this is also something that you might want to copy into your notes. It has, here's an example of the different equations, and it's got kind of the, if it's got compounds or elements, they're labeled. If it's got specific things like, you know, acid, base, salt, water, it's labeled. Here's combustion with oxygen, carbon dioxide, and water. Here's the precipitation where it has the solid product labeled, okay? So it has a lot of the different things we talked about labeled. And then here it tells you which of the reactions we would categorize it as, and then it tells you that type, is it redox or double replacement, okay? And so we can see that, acid base is double replacement and precipitation is double replacement. The other 4 all fall into the redox category. Down here, it has a list. There are several, let's see, what is there? 1, 2, 3, 4. There's 7 different chemical equations. You're telling me, so reaction is this first column. Okay, so reaction is where you're telling me is it acid base, synthesis, decomposition, single replacement, combustion, or precipitation. And then under the second column, type of reaction, that's where you're telling me which of the main 2 types. Is it double replacement or is it redox? Okay, so, and all you'll do is you'll drag these into the boxes. Some of them you only use once. There are some that you'll use a couple times. Okay, and again, you can use this image up here as your guide to help you. The second part, so when you're done with that, then you'll go to page 2, or actually, when you're done, you can hit check. Then you'll go on to page 2, and page 2, it says demonstration of learning, start quiz. It recommends this button right here. This is the full screen button. If you start it, it's not going to be, very nice to look at. So you can click this button here, and what you're going to see is it's going to go to full screen so that you can see everything, and then you can start it. You'll go through the questions. I believe they are all multiple choice. And then when you are done with both of those things, then you will go to page 3. And page 3 has kind of the summary of how you did. And then you will hit right here, this green button that says submit report. Okay. If you don't do that, then I'm probably not going to get the grade. And then you're going to end up seeing like a missing in the grade book once I grade these over the weekend. Okay. So that is what you were working on today. Oh, let me go ahead and show you guys the other part. The extra practice that's on here, if you would like to do it, is this one right here. So you can see it doesn't count towards your grade, but it's types of reactions vocabulary. It says click on start game, and you're going to match the chemical reaction terms with their definition. You can select learn from the choose a study mode if you need more practice, and then it says when you're comfortable, you can assess yourself by selecting test or choose a study mode. And so it says make everything disappear, match all the terms with their definitions. If you pick the wrong match, extra time will be added. So if I hit start, and then it's going to pop up like this. So like I might be like, okay, synthesis. What is synthesis? Well, this equation looks like synthesis, 2 things making 1 compound. So I'm going to click on both of those, and then they disappear because I got it right. Okay. Decomposition, I have 1 thing and it breaks down into 2 things. So I would click that. Single displacement, that's another term for single replacement. I don't see, this is not single replacement. So that means it's probably one of these definitions. Okay. Let's see. Type of double displacement, that's not it. Positive ion of 1 compound replaces the positive ion in another to form 2 new compounds. That's not it, because a single replacement has an element in a compound. So it's got to be this last one. 1 element trades places with another in a compound. And so that's what you'll do. You can kind of practice that. There's a study mode here where, like it says, you can do a test or learn. But even if you redo it, so I'll just go ahead and finish this. So combustion, double displacement, and then this is acid base. So it's going to tell me, and so I can play again, but watch, if I hit play again, they're going to look different. Okay, they're going to be different. See, I got different things. So even if you don't do the study mode stuff, it's going to be different if you redo it. Okay. All right, so that is what you guys have on tap today. Do you guys have any questions